This call is now being recorded.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Today it will be a little bit different that we usually do every week because in this time we do the lecture asynchronously, which means that I already upload this subject in the YouTube and you can just watch it on YouTube. And the reason why I just do that because I have an annual leave today, so I cannot teach you on live in the real time. So instead, I already record this before and then upload it in YouTube. So you can learn it by opening the video on YouTube. And I hope that the transferring knowledge process will not be uh, more difficult because of that. You can still ask me the questions if you want to ask me something related to the PLC programming using the WhatsApp. And for the subject, I will give you the assignment also for the last meeting and this meeting. So the assignment will be related to the counter and also the comparison function. So today we will learn about the comparison function in PLC Show Machine, which is something that is maybe a little bit different than counter or timer, and also the arithmetic function. So for today's meeting, the subject will be comparison and also arithmetic function. But we will use the knowledge that we get from last week or to last week meeting about the timer and also the counter, especially related to the value timer and also value counter and the preset timer and also the preset counter. So without further ado, this is the subject. Uh, so let me introduce first about the integer address. Uh, Maybe I have to explain to you all about what is integer. Integer mean integer. I mean that it is different with float. With float, you can just give the number 0 point something. For example, 0.1, 0.55, 0.63. That is not integer. Integer means that the number must be rounded. For example, 1, 2, 3, 5, 70. Negative 1, negative 50, also integer. So the integer number that we can use is depend on the bit or the device that we use. And in this case, in the PLC hardware that we use, which is some machine or maybe Modicon TM221, the some machine is the software. The integer number that we can use will range from negative 32,768 until 32,767. So the number will be limited to the range between those numbers. So any number that higher than 32,767 or less than negative 32,768 is not allowed in this case. So this is the maximum number to be put in a memory word. So in this case, if we want to store the number, which means that we want to put the number into a certain storage, you can put it in the memory word. So we already established the situation. We want just to write the Boolean number using the memory. internal memory, and we can use percent M1, percent M2, percent M3, percent M something. That is for Boolean number. So the situation in that memory address only occur between 0 and 1. So if it is active, the logic will be 0, and if it is, sorry, if it is not active, the logic will be 0, and if it is active, the logic will be 1. But it depends on the situation whether the input is normally closed or normally open. So this is the normal situation. But in this case, if we want to put the number, for example, 100, you can just put it in the percent MW something. Why I say that? Because percent MW can be percent MW0, percent MW1, and so on. But the number for percent MW is limited. So we just want to see how many MW that we can use here. So we will back to the Soul Machine software again, and we want to see, yes, how many MW that we can use here. We can use the operation block number here to put any number between those ranges. And I want to explain to you that it depends on the PLC that we want to use. For other type of PLC, maybe the number will be greater than that. There are also double memory word, so the number will be much higher than that. But because it is for the normal memory word, the number will be limited. Okay, so I just want to put a certain number inside percent MW 512, and then you just put here. This is how you put the number inside the percent MW 512. We want to put the number 1000. Can we just do that? Okay, we can just do that. So percent MW 512 is something that we can use. How about if we want to use other type of number? Okay, percent MW 513. We can still use that. Okay, we will make it a little bit higher. 1000 and oh my god, this is something that we have to be careful here. Then MW 1024. Okay, we cannot use that. Oh, I'm sorry, there's some mistake here. You can just still use that. Okay, so it will be limited as a number 5,000. Okay, we cannot use the number 5,000, so the number will must be lower than that, 2,048. 2047. 1,999. Okay. So we just want to make some kind of reset. How many MW that we can use? Okay. So this is actually a very interesting situation here. We can see that the memory word that we can use is actually start with number MW0 until MW 1999. So there are 2000 memory words that we can use here. So Yeah, there are plenty of that, so we don't have to be afraid that we will run out the memory word. And now we want just to see uh, the number that we want to put it here, negative 32,769. For example, we cannot put it, but for 68, we can put it here. So there is no problem here. This is the minimum number that we can put inside the memory word. So the memory word address that we can use in this soul machine is between 0 until 1999. And for the number itself that we can store inside the memory word is between negative 32,768 until 32,767. This is the number that you have to put in mind because not every number you can store in it, and not every memory word number you can use. Okay, so this is basically the situation that we have, but it is pretty unique. Maybe there are other type PLC who has the similar characteristic, but uh, for other type of PLC, maybe the PLC with a larger memory, maybe we can store as uh, more more memory word than that. Yeah. So it depends on the type of the PLC that we use. Maybe if we work in a certain company or maybe an industrial area, then you use a PLC that the type is different than this type, and you see that there is the difference, how many memory word that you can use, then it's not something that is very special. It's something that's very common. That every PLC has different characteristics, but the syntax usually the same. Okay, we will back to this, yeah, to the integer address. So we can already know that the storage is from percent MW0 until percent MW1999. And MW means memory word. If you find MD, it means that memory double word. So the number that you can store actually much larger than that. Okay, so the third one here actually we already show you. If we want to put an integer number into storage one, we write this percent MW1, yeah, double dot equivalent with integer number, yeah, integer number. So for example, percent MW0 equivalent with 3000. It means that we put the number 3000 inside the memory word 0. But you cannot write it something like this. For example, you want to put here, but the situation is actually opposite. You cannot do this. So the storage must be in the left. You can make it something like this. You want to put other storage into another storage. It can be something like this. There's nothing wrong with this. But at the left side must be the storage, must be the place where we want to put the number. We can put another storage into another storage. There's no problem with it. Okay. Okay, so this is the example. We want to put the 3000 inside the memory word 0. And then the comparison function, there are actually many comparison functions that we will use. and it is very familiar with the arithmetic function that we usually use, so it's not something that is very special. So the comparison function actually has a purpose to compare two different numbers. Actually, not only two, maybe three, four, or five, but we have to do it sequentially. And the type of double number must be the same. For example, if you want to compare integer, you have to compare it with another integer, not with float, not with boolean. Yeah. And the comparison symbol is something that is very common and we usually use it. For example, this is the symbol for greater than. This is the symbol for greater than, less than, equivalent, less than, sorry, less than equivalent, yeah, less equivalent than, yeah, less equivalent than, greater equivalent, and not equivalent. So that is the comparison function that we can use. For example, in this case, the number is that percent MW1 is not equivalent with the number inside percent MW2, then the output percent Q0.0 will not be active. So if, yeah, I have to put the word if here, if the number inside percent MW1 is equivalent with the number inside percent MW2, then the output percent Q0.0 will not be active. So there are many types of integer that we can use. If you want to make a comparison function, you can just click it, click this. Yeah. I just want to show you many different type of comparison and then the output. So you can compare another memory word with other memory word, number with number. I don't know if you can use it. No, you can put uh, something like this. You have to put number with memory word. The key 0.0. Okay, for example, something like this. Okay. So you can make it something like this. I just want to make it higher. So actually, you compare the memory word, the memory word with a fixed number. You can also compare a memory word with other memory word, something like this. But you cannot put the fixed number here. So at the left side, it must be memory word, and at the right side, it can be a fixed number or other memory word. So we actually compare the number that we store inside the memory. And how we put it, we can just use the arithmetic functions there. Okay. So we want to compare the memory word 88 with the memory word 99. Okay, we insert the run because why? We have to establish, yeah, we have to put the number inside the memory word 88 and 99. Because if we don't put it something inside it, it means that the number inside of both storage is zero. So there will be no problem if we want to compare 0 but 0, but it will be useless. So if we want to put a certain number inside memory word ATI, we put something like this. For example, we compare the number 100. And why is something mistake here? You cannot just put two run here. So you have to delete one of these. Yeah, just delete it. You have to add another run. Okay. So this is still not finished. Insert run. And then this time we put a number inside memory word 99. Okay, so the memory word 88 will it consists number 100, and the memory word 99 will consist the number 98. So if the memory word of 88 is less than the memory word of 99, the lamp will be or the output U0.0 will be active. So we want to see what happened here. Okay, start the controller here. So yeah, we see that if 100 is less than 98, the lamp will be active. But we already know that 100 is greater than 98. So the lamp is still off, the output will be logic 0. So how to make it right? We can just change the comparison. For example, okay, I just want to put it something like this. It's actually greater than. It's actually greater than. So we can see that 100 is actually greater than 98. So the output percent Q0.0 will be active. And you don't have to confuse with the fact that the comparison symbol always like this. It is only a symbol. So no matter the comparison function that we will use here, the block here always use the less than. For example, I just want to use equivalent. The limit will be off again. Because why? Because this is of course not equivalent. 100 is not equivalent with 98. So the line will be off again. So if we want to use another type of comparison, we can just put it here. What if we want to make it something like this? What if the number inside memory 188 is different than the number inside memory 199? So we want to modify it first, and then we can see that the output Q0.0 is active again because actually it's different. 100 is different with 98. So it is very easy. Yeah, you want to compare something like this, and we can make many type of comparison. For example, we want to use different memory address, or maybe something that is the same. It make it serial. So we want to use fixed number here. So in this case, what we can infer from this equation is that if the memory word 88 is different than the memory word of 99, and memory word 88 is greater than 50, then the line will be on. So we can put the comparison function here, 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 or we can make it parallel. So it's up to us. You can also make a program something like this, even though it doesn't make any sense. But yeah, it is something that you can do. Okay, so this is comparison. We already established many variation of that. Greater than, equivalent. Actually, if we want to make the greater equivalent, we can just use it here. Okay. You have to be careful with the syntax here. Simulator. We want to try another type of function here. So this is the greater equivalent and in less equivalent. We can just put the equivalent function after greater or less. What happens if you just do the opposite there? What happens if you put the equivalent first and then this, yeah, this is something that is very wrong here. So you have to put the equivalent after greater or less than. If we put the equivalent first, then it will be error. Okay, so this is the comparison function. Uh, and maybe the most important thing is that we can actually compare the value timer, the value counter, the preset timer, and the preset counter. By using the comparison for timer and for counter, we can make the graphical light system easily because we can just compare the value of the timer of the or the value of the counter, and then we don't have to use many timers or many counters to do something that is very simple like traffic lights. Okay, so I want to make a very simple traffic light system using only one timer and using only one timer. So first we have to delete this and we will back to the timer. I'm sorry, this is counter. This is the timer, and then we want to change the type. And the number here, time pulse, and then okay, I just want to see what happens here. Don't forget to start the controller here, and we can see the number will goes up from 0 until 10, and then it will go back. We want to use the situation to compare the value of the timer, and then we will make something happen. We already makes the number round and rounding again. We want to compare the value of that number, of the value timer. So here we want to compare the value of the timer. If the value of the timer, which is TM, and in this case we use TM0, so TM0 dot view dot v, I mean, is more than or equivalent with 0. Okay, okay, so we have to make it from the very beginning again. It is something a little bit difficult with this. But it is still below 4 out of or 5. So then the output one will be active. If the tm0.view.v is greater or equivalent than 5, but still below the number equivalent number 6%, then the output 2 will be active, or Q01. And if the number is greater than 6, the output will be Q0.2. Okay, so what happened then? We launch the simulator here. Let's see here. Maybe like traffic light. When the value is between 0 until 4 or to 5, the Q0.0 will be active. If the value between 5 and 6, the output Q0.1 will be active. And if the number of value of timer is greater than 6, the output Q0.2 will be active. And will be repeated again because the value of the timer is always goes from 0 until 10 and then it will be back to 0 again. So in this case, we can create the traffic light system using only one timer. And using only one timer. And not only that, we can also make a comparison for counter. We can make a comparison for counter. So if you want to activate it many outputs using just one counter, you can just do it here. Example, or you use a very basic counter here. I 0.5, it's up to me. And actually, the preset number cannot, maybe you just want to make it 9,999, but you want to establish three different output. I want to add something to make it back. Yeah, to make it back. If the value is different with 10, So we can see it here that the counter up, the input I 0.5 is connected to the counter up. And every time we press the I 0.5, the value of the counter will be changed, will add up from 0, 1, 2, 3, 4, 5. And then we make a situation if the value of the counter is between a certain number, a certain output will be active. And after it reaches the number of 10, the value counter is equivalent with 10, it will activate M1, memory 1, and then the memory 1 will reset it. So what happens? We can just see it here. What happened there? Okay, so, so we added one. There's nothing happened. Because the output Q 0.4 will only be active if the value of the counter is between 3 and 7. So we add up again. And 3, not because it must above 3. And then the 4, the output is active because the 4 is located between 3 and 7. There's nothing wrong with this. We continue press the push button here. And then it hits 8. What happened there? The output Q 0.5 will never be active in this situation because the output Q 0.5 will only be active if the number is between 7 and greater than 7 and less than 8, but at the same time it must be integer. There is no integer number between 7 and 8. Yeah, so that's something that never happens. And then if the value is between 8 and 10, the output Q 0.6 will be active here. Okay, 9, and then 10. When the number is 10, the M1 will be active, and it is active, reset, so the value will be back to 0 again. So something will repeat it once again. So we can see it here that actually the preset is kind of useless here. We can we can just put any preset number that we want, but we already know that the number every time we press the I 0.5 will change until 10. When it reaches 10, the M1 will be active and it will reset the count. That is how we merge the timer, the value timer, and also the value counter with the comparison function. And it makes the program so much easier. Yeah. Because if you want to make a traffic light, we don't have to use three timers. We can just use one timer. And also, if we want to, make something like running LED using a counter, we can just make a one counter and then makes the comparison function based on how many times we press the input or make the input active in this case. Okay, so that is how we compare the value and the value counter. And if you want to use the preset timer here, yeah, you can use this. Yeah. Well, usually we don't compare it, but we put it in a certain number. For example, this. If we want to change the preset here, you can just add something here. Okay. insert from, and then I just want to change the preset of the timer here. So we know that we use the address 0 for the timer, and we want to put the number of maybe 15. Oh God, no, no, we have to. And then the value of timer will be changed. I 0.6 in this case. So what happens? Okay, we can see that the timer is still counting until 10. What happens if we press the I06 here? It will change the preset until 15. So it will count until 15. What if we want to make several presets? We can just do that. If we add one, it will be put as below. So actually, I just want to make it more neat. So insert one will be more sufficient here. Okay. I just want to put it back to 10. I 0.7. Okay, we can see that it count until 10. We want to change it to count until 15, but it still will count until 10 because it still stores the last number. And right now it will count until 15. And if we want to make it back to count until 10, just press the I07 here. Okay, so for the next rounding, it will be back to count until 10. So that is how we put different preset for the timer if we want to activate something. So how we change the preset for the counter here. It's actually almost the same syntax here. There's nothing special in it. This is F1. If you want to change the preset number for counter, we can just do the same. Percent C0 dot P equivalent with, for example, 12. Okay, and then we activate something else, M100, for example. So every time we press M100, the the physical count will change to 12. But in this program, unfortunately, it's kind of useless because we know that, uh, you know, uh, until it reaches 10, the counter will be reset. Well, we can see that there is something that is changed here from 9,999 to 12. So that is actually how we change the reset number here. Okay, so so we can just see how we change that. So this is the program example. When the timer value is above 3, then the output will be active. I already show you. And then this is the arithmetic function here. So we can actually make an arithmetic function plus, this is for add two operands, subtract two operands here. So it's something that very familiar with the here with us. And then the star here to multiply two operands and then divide two operands here. This is the remainder of division of the two operands. Square root of an operand, increment and decrement. So this is how we want to make a certain example here. So in this case, MW0 will contain the number that is the adder between MW10 with 100. For example, if you already established that MW10 contains number 10 or contains a number 50, for example, then the MW0 will consist number of 150 if we press the M0. And this also will happen if we use the square root of MW10 and we put it in the MW0 after we activate the number of I 0.2. And if you want to make an increment for MW100, you have to make sure that you use this rising edge. You use the rising edge. That is the most important aspect here. You cannot use a normal open or normally closed system here. Okay, so I just want to give you the example here. Okay, maybe it will be better if we save it. And then open a new one. Okay, so it will be better if we make it by case. Okay, so if you want to enter the values of 10, 20 and 50 to MW1, MW2, and MW5. Then we multiply the number inside the MW1 by MW2. The result will be reduced by the number inside MW5. Okay, so this is the first case. How to make it happen? Then we establish the three different arithmetic function first here. 1, 2, 3. Okay, so we want to put three different number, 10, 20, and 50. 1, 2, and 5. Do not forget to click this. Sometimes it can be annoying if we don't click that first. Percent MW1 is equivalent with 10. Percent MW2 is equivalent with 20. And percent MW5 is equivalent with 50. Okay, so we already put all the number inside the memory word. And then we have to multiply MW1 with MW2. So we can just multiply it. But you have to store the result of the multiplication. And because we don't know, or we didn't get any information about the address for the storing the result of this multiplying, then we can just put any memory word. So for example, I just want to use the memory word 100 is equivalent with the multiplication of MW1 with MW2. Okay, so this is the result of the multiplication between MW1 and MW2. And then we want to reduce the result by MW5. So percent MW, because we didn't give any information how to put the result, then we can just put it any free memory word that we haven't used yet. So we can see that it's quite a very neat and nice program here. Okay, so we can see it. The MW1 will consist the number of 10, MW2 will consist the number of 20, and MW5 will consist the number of 50. And then we multiply the number of 10 with 20, which is in this case is the storage that is the number that is stored in MW1 and MW2. And we put it in MW100. And then we reduce the number in MW100 with the number inside the MW5, and we store the result in MW200. And we can see it that it can calculate perfectly. So that is how we solve the number 1 here. It's very easy. And then the number 2, create a function of 25 sin 300 degree. The result is stored in MW5, then the multiply result by 10 logarithmic 200. The result is stored in MW15. So it is a little bit more complicated than the previous assignment, but we can still do that. we can still do that. So maybe we can just save it and then try number 1. We stop the simulator here. Okay, we use the usual PLC and we start the number 2. Okay, we start the number 2 by put in the float. Okay, so for number 2, we cannot use the integer function. Why? Because it requires something that is between the number 0 and 1, 0 point something number. And we cannot use the type of memory word because we have to use the real number or the float. So for example, float is some storage that we can store the number that is something like this. 25.367, for example, 1.255. It is something that is not rounded number. So we have to use the memory float here. So how we make the memory float? So it's something like this. This is the memory float. If you want to put the number 300, you can just do this. But don't forget the point here. I'm sorry. This is, you have to put first, I'm sorry, this is some kind of percent MF10. Okay. So in this case, if you put the float number, you can see that this is 300. But in order to make the difference between the float number and the integer number, we don't have to put point 0 here. The program will do it for us. So even though we type the number 300 here and then press enter, it will automatically change into 300.0, and it's not a problem. It just want to show us that it is a float number, not an integer number. Okay, so this is the float that we want to use. MF10 is consists the number of float 300. But yes, what is this 300? The sinus function can only be applied to radian here. So we have to change the number into radian. So this is how many function that we can use here. And we have to store it at a different memory float address. For example, 30 here. And we want to change from degree to radian. And it is actually very helpful here. 4% MF10. So basically, this program told us that we change the 300 from degree to radian. And why we do that? Because we want to make a sinus function. In this type of program, the sinus function can only be applied to a radian. So it is something that is very common. I mean that you usually sin 300 degrees, something that is very common. But this PLC can only process the sinus function for radian. So you have to change every degree or every type of angular with radian. And then we can just put a sin here, sinus. Percent MF40 sin 30. Okay, we want to check it. We want to check it. Okay, so we can see it here. We can see it here. We can see it. Okay, that 300, when you change it to radian, will change to 5.23, and sin 5.23 radian is equivalent with negative 0.86 something, and it's right. So we stop the simulator and we continue here. So we already established the number of sinus 300, but we have to multiply it by 25, and this have to be in also float number. So we have to multiply MF40 with 25, and we can put it in MF50. Can we just do this? Let's check it out. So in this case, we multiply the MF40 with 25. We only put the number 25 here, but the program will correct itself by putting this point 0 here. So there's no problem with that. Okay, so then we continue, and the result is stored in MW5. How we just do that? We change the float into integer by using floating real to integer function. So percent %MW5 actually real to integer percent %MF50 here. Okay, there's something wrong here. I forget the equivalent. That is very important here. Okay. So we can see what is the result here. So we can see that the float number is actually negative 21.6 something. And if we change it into an integer number, the number will run up into negative 22. Because integer means that there is no something between 0 and 1. There is no point something in integer. The number is rounded. So it will change into negative 22. And there's nothing wrong with that. Okay, we continue then with the logarithmic function. Tan logarithmic 200. And we have to use also the float number, because logarithmic is something that is used a real number. And in this case, we can just put MF60 is equivalent, with log. Can we just do that? 200. MF60 is equivalent with log 200. So we don't have to put 200 into a certain float address. We can just put exactly 200 in this logarithmic function. And then we multiply it by 10, and the result multiply it by 10. Okay, we multiply it, and then we have to multiply it with the this with MW5. So we have to change MF70 into integer number also. Because we cannot multiply float with integer, we have to multiply integer with integer or float with float. And then what happens here? We multiply MW60 with MW5 and storage it in the MW15. So let's see the result. Okay, there's something wrong here. Oh, we cannot just put it in. We have to change it. Unfortunately, we cannot make it something happen, something like this. So we have to store the number first. For example, percent MF 110. So we can see it here. The logarithmic of 200 is 2.29 something. And then we multiply it by 10, then the result will be 23 point something here. And then if we change it to integer, the number will be 23. And then we multiply negative 22 with 23. The result is negative 506 that will be stored in MW15 here. So we can see that is quite long and complicated here. We have to change, we have to put the float number first, and then after that we change it to radian by using the syntax degree to radian, and then we make a sinus function for that, multiply it by 25 and change it to integer by real to integer. And then for the logarithmic function, we put 200 here inside MF 110, and then make a logarithmic function of 110 into MF60, and then we multiply MF60 with 10, and then make a real to integer for MW60, and we multiply the result of MW5 with MW60 and put it in MW15. Like a previous slide, it is a little bit long and complicated, but we can still do that. Okay, so this is the number 3. Create an increment program, and then the result is saved in percent MW5. Then press the input several times so that the MW5 value is increases. Compare the result with 5. If the value is below 5, the output 1 is on. The value is equivalent with 5 of the 2 is on, and if the value is above 5, the output 1 is blinking or flip-flopping. Okay, so we can just store it then. Number 2 or number 2, okay. Okay, so this is for the number 3. It's a little bit different situation or a different programming. Okay, we want to create an increment program, and I already told you that you have to use the rising age system here and make increment. Okay, MW5 increment. And this is only the number here. Okay, so we don't specify the input, so we can just put any input. So we put the input 10.0, and this is the increment here. What happened then? We just see. We press it, then we can see that the number is changed. Yeah. So back then, stop the simulator, and yeah, we continue the assignment here. And compare the result with 5. Okay, compare the result with 5. So don't you ever forget. This is the MW5 that we compare. So below 5, output 1 will be on. So if the percent MW5 is below 5, the output 1 will be on. But we just want to put something else here first. MW is M0. Why? Maybe it will be clear after we make this program. If it is equivalent with 5, then the output 2 will active, because there's something not something special with it. We just put the output 2. And the value is above 5, the output 1 is blinking. So we have to use a flip-flopping again. we use and create the blinking function. We just want to every 1 second here. So this is the flip-flopping program. And we make a parallel between M0 and M1 here to activate Q0.1. Why we make it? Because we don't want to make the number of output 0.1 is more than 1. It must be limited to 1. So this is the program. You want to see it, whether it is right or whether there is something that is still not right here. Okay, so 0 actually below 5, so the lamp 1, so the output 1 will be active. Yeah, it is right. So we increase it. When it's equivalent with 5, the output 2 will be active. And if it is above 5, this will be blinking. So this is the program for this assignment. So we can see that it is very, very simple actually. Yes. It is very, very, very simple. So we continue the number for the number 4 is actually easy. Multiply the values 9, 15, 6, and 8. The result is then added to 100 and stored in MW8. I can imagine that you can do it by yourself. And when push button is pressed, at the 3rd second, output 1 is on. At the 6th second, output 2 is on. At the 8th second, output 3 is on. Using one timer and comparison function. It's all very easy. Okay, so the remaining task will be your like assignment, and I will put it inside the Google Drive, and you have to give it back to me the next week, yeah, after this. And next week we will try many application using a counter and timer, and then also there will be quizzes for next week. So next week we will meet 2 times, Friday and also Saturday. It depends on our appointment situation. If you have times to meet once more, then there will be quiz, because 2 weeks from now there will be mid examination. because we already meet 7 times, and the meet examination happens after the seventh meeting. Yes, so, yeah, so this is the first time that I teach you on YouTube. I hope that you will be more familiar with it because yeah, if we cannot, meet online in real time, maybe I will use this way. I hope that there will be no problem here because it is something that is very common nowadays. When you can just store or you can just put the lecture into a website and you can just access it anytime that you want. So here it's for today. I hope that you understand it. If there's something that you want to ask, you can just use the WhatsApp and ask me the question related to the subject or maybe yeah, other subject. Yeah, I mean in PLC, of course, not in other lecture. So I think it is enough for our meeting today. Assalamualaikum warahmatullahi wabarakatuh.